Hello everyone. In this lecture we are going to discuss about the stack data structure and we are going to implement it in Python. And trust me, if you ever implemented stack in C, then you'll love its implementation in Python because it would be so easy. So let's get to the basics. So here we go. So stack is a linear data structure in which the data is arranged linearly, just like that. But that's what happened in arrays also. So what would make stack different? So there's a restriction which makes stack very different from array. In stack, if you have to insert an element or remove an element, then you can do it from the topmost value of the stack. Okay, which we call as the top of the stack. This thing, top. Okay, now what top does? Top just tell us the uppermost value of the stack. So now there are two operations, basically two operations, which we consider as the main operations of the stack. First is push, which is simply adding an element, and other is pop, which is removing an element. So first we will discuss about the push operation. So in push operation, we have a stack which upper, like we just put the values, value 1, value 2, value 3, value 4, value 5, and we have the top which is pointing to the value 5. So this is the topmost value. If we want to add this value x, wait, let me check on this. If we want to add this value to the stack, then we can do it at the topmost value of stack. Okay, so this value x would be inserted here, and now the new top would be this one. That's it. So that's the basic operation of stack. The push operation. So after the implementation, after this push operation, see, this value x is inserted at the top and the new top value changes. So what is what's the conclusion? That in a push operation we just add a element at the top and the value of top changes. Now what about pop? In pop we simply remove the element and this value would be returned to us. This value is not deleted. We are not deleting this element. We are just taking it out and seeing this element. I mean, we know what that value is which we are removing from the stack. So in this it would be our output. Okay, so that means the pop function will give us an output, and push function would not give us an output. It will just upgrade our stack, but it will also upgrade our stack, but pop function, and it will give us an output as well. So in this the value of top decreases, see, after the pop function. So let's code it out. You will love the Python implementation. So we are now at the Jupyter notebook, and first we will define a class which name stack. Now we will initialize the values in it, self, and we will say self dot values equal to an empty list. That's it. So basically whatever operation we are going to perform in stack, that is simply list in Python. Okay, now what if we define a push operation? It will take let me make it small p, and it will take an argument which we say data, and it will simply self dot values dot append data. If you know the append function, then it simply adds the element at the last of the list. That's what we do in the stack. Now we'll define our pop function. It says self, and it wouldn't take any argument, but it will return something. What it would return? It returns self dot values dot pop. So what pop operation does without taking any index, it just returns out the last element and change the list as well. That's what we are doing here. Now we'll define some other basic functions like is empty. It will check that if the stack is empty or not. So it will return us that whether the length of self dot values, that is our stack, is equal to 0 or not. And we will define a function def size, which will return us the length of self dot values. So we got our 5 functions here: push, pop, is empty, size. Okay, so now we are going to implement it. So we'll say there is our s equal to a stack, and we will first push the value 1. So we are going to push, we'll pushing some string elements just to make it more clear. Then we'll print s dot values. Let me put a print here. Now we'll say s dot push value 2, and it will print us s dot values one more time, s dot push value 3, and we are going to print s dot values one more time. So what we are going to do, that at the very beginning we are going to define s as a stack, and initially self dot values would be an empty list. So initially s didn't have any value. So if we are going to print s dot values at the very beginning, it will return us an empty list. Then we'll push the value 1, then value 2, then value 3, and we are going to print the s dot values one by one all the time. Okay, let me add some more nodes. Okay, now we'll perform s dot pop operation, and we are going to do we don't have to pass anything in it, and we are going to print s dot values one more time, and we are again going to pop, then we are going to again print s dot values, then we are going to again pop, and then we are going to again print s dot values. Now we have pushed 3 elements and pop out 3 elements. That means that there would be no any element remaining. So now when I call s dot is empty, it will return us a true value, and s dot size will also return us some values. So let's run it and check if our implementation is correct or not. Okay, so initially when we print s dot values, there is an empty value. Then if then we push value 1, so it will have value 1. Then we push value 2, then it will have value 2. After that value 3, then we pop out the value 3, so it returns value 2. Then pop out the value 2, then it returns value 1, and at the end it returns us s dot value. S dot is empty is not returning anything. Let me check once. Is empty self dot values. So if we remove the s dot size and now run it, so we'll get our true. And if you want to get s dot size, we'll get it at 0 because nothing is left at the last. So that is the stack implementation. Hope you get all the points and this diagram correctly. Now if you like the if you understand the video, please like. If you have any doubt, make sure to leave it in the comment. And for a small appreciation and for more support, please subscribe the channel. Thank you so much. See you at the next lecture.